Our instructions for these problems, these last four problems, are to find all the roots. So up until now, all we have found were the rational roots. So we used our calculator, we tested the possibilities, we figured out which ones gave us a y value of 0. So that step has already been done for us in these problems. So that's why you see under the problem it tells you if there are rational roots and what they are. So what I want to do today is go through with you how you solve an entire problem using this given rational root. So I have the steps written out on the right side there. For step 1, it says factor out a greatest common factor if possible. And what that's really talking about is if you have a variable. So if I had an x in all four of these terms, I could factor that out and that would give me one of my answers. In this problem, we don't have a greatest common factor. There aren't any common factors in all these terms. So I'm just going to put a check mark next to step 1 because that one, it's not possible. So we'll just say it's done. Step 2, use the rational root theorem to find the rational root. So if you were actually doing an entire problem start to finish without anything given to you, you would do what we did in the previous lesson and you would use your calculator to test all the possibilities and you would eventually come out with that your rational root is x equals 3. So I'm going to put a check mark next to step 2 because that is already done and it's this part right here. So steps 3 and 4 are really the new part of today. So it says divide out rational roots using synthetic division. So I was given a rational root, which was x equals 3. You may be thinking when we did synthetic division, you always had to change the sign of the number that you were given. You do not need to change the sign in this one, and the reason is because we're given that x equals 3. Previously, so before when we learned synthetic division, you were given something like x minus 3. You were given a factor, not a solution. So if you're given a factor, then you have to change the sign. If you're given a solution like x equals 3, you do not change the sign. So step 3, I'm going to label it step 3, is to use synthetic division to divide out the rational root. So I'm going to put a positive 3. Remember, I'm not changing the sign. And then I'm going to put down all my coefficients. 3, negative 10, 4, negative 3. And now we'll go through the process of synthetic division. So I'm going to bring down my 3. 3 times 3 is 9. Negative 10 plus 9 is negative 1. 3 times negative 1 is negative 3. 4 minus 3 is 1. 3 times 3 is 3. And finally, negative 3 plus 3 is 0. Now, something very, very important is this last number in your synthetic division must be 0. If it's not 0, one of two things has happened. Either you did your synthetic division incorrectly, in which case you should go back and double check it, or maybe your rational root was wrong. Now that's not going to happen today because we're being given the rational root. That's guaranteed to be correct. But if you were doing it by yourself, then you would want to make sure that that comes out to be 0 because it could mean that your rational root was wrong. All right, so we've completed step 3. Our final step, step 4, is to use the quadratic formula to find the remaining roots. So remember when you do synthetic division, your answer is 1 degree less than your problem. So since our problem was x cubed, that means that our answer is going to start with x squared, x, and then our constant. So if I were to rewrite this out as a polynomial, as an answer, I would write, and I'm going to write it over here, it would be 3x squared minus 1x plus 1. And you really don't need that 1 in the middle. But that's what that polynomial would look like after it got divided. When we do quadratic formula, all we need are the a, b, and c values. So from now on, instead of doing what I just did, we can skip over that step. Basically, this is going to be your a, b, and c listed out. Okay, so those numbers that you get from synthetic division are automatically your a, b, and c for quadratic formula. So I'm going to write that down over here. So a is 3, b is negative 1, c is positive 1. Now I'm going to take those three numbers and plug them into the quadratic formula. That's going to give me my remaining solutions. Now remember that because the highest exponent on my function here is 3, that means I should get 3 total answers. I was given one of them. That was the rational root, so the other 2 are going to come from the quadratic formula. So the quadratic formula I'm going to rewrite up here, negative b plus or minus the square root of b squared minus 4ac divided by 2a. So we're going to plug these numbers in here. So I have x equals, my b value is -1. So if I have -1, that's actually going to turn into +1, plus or minus the square root of b squared, which is -1, minus 4 times a times c, and that is all over 2 times a, which is 3. I almost wrote the answer. Okay, so now I have to do some simplifying. The 1 is not going to change. I want to figure out what goes under the radical. So what I like to do with these, because if you're using Desmos or the certain other calculators, they don't reduce radicals for you. So I just type in what's inside the radical, and it gives me -11. So when I rewrite this, I'm going to replace everything that was under the radical with -11, and then 2 times 3 is 6. There's only one thing that we need to do, because 11 is a prime number. I can't break that down. I can't do a factor tree with it. The radical isn't going to reduce. The only thing that we can change is that negative under the radical. Anytime you have a negative under a radical, that has to come outside in front of the radical as an I, as an imaginary number. So my final answer for my last 2 roots is 1 plus or minus the I for the negative under the radical, the 11 stays underneath, and then the 6. I can't reduce anything else. The only way I could reduce would be if all 3 of my outside numbers were divisible by the same thing, which they are not. So here are 2 of my answers, along with the rational root I was given. That's my 3rd answer for a total of 3 roots altogether. Step 1 is always to factor out a greatest common factor if possible. And in this problem, it is possible, because if you look at all 4 of my terms, everything has x. So what I'm going to do for step 1 is I'm going to rewrite this problem, f of x equals, and I'm going to take that x that they all have in common and put it out in the front. It's not going to change any of my numbers, but it will drop all of my exponents down by 1. So this is still going to be 2, but now it'll be x cubed. Minus 7, this goes down to x squared, minus 4x to the first, but I don't have to write the 1, and then plus plain 20. Okay, so that was step 1. I factored out my greatest common factor if possible. Now, this gives me one of my rational roots, because I can now take each part of my equation and set it equal to 0. So if I set x equal to 0, there's one of my rational roots right there. So that's where this rational root comes from. The other rational root, which is +2, that comes from the rational root test. So that's where you would put the function in your calculator and test all the possible rational roots. You would find that the value x equals 2 gives you a 0 when you evaluate it. So that's where those first two solutions come from. Okay, now when I start with step 3, I have to use synthetic division. This is a little bit tricky because I don't have to worry about that 0 anymore. I'm going to go straight to using the 2. And the reason I don't have to use the 0 is because I've already factored it out. So now when I do step 3, I'm going to be using this function. So what was left over after I took that x out. So for step 3, I'm going to do synthetic division with the number 2. And remember, I'm not changing the sign because I was given a solution and not a factor. Okay, so I'm going to put in all my coefficients, 2, -7, -4, and 20. And now I have to go through the process of synthetic division so that I can find my a, b, and c values for step 4. So I'm going to bring down my 2. 2 times 2 is 4. If I add down, I get -3. 2 times -3 is -6. If I add down, I get -10. 2 times -10 is -20. And if I add down, I get 0, which remember, you have to get. If you don't get 0, something is wrong. So I am now officially done with step 3. And remember that these values that I just came up with, those are my A, B, and C values for the next step, which is to use the quadratic formula. So step 4, we're going to be using the quadratic formula. So I have x equals negative b. Since b is already negative, that negative 3 turns positive. That first thing always flips the sign of whatever b is. Plus or minus the square root of b squared. So I've got negative 3 squared. Very important that you have the parentheses around the negative 3. Minus 4 times a times c. And then all of that is over 2 times a. The next thing that I would do is take everything that's under the radical and put it in my calculator without the square root and see what number I'm going to replace inside the radical. So I have x equals 3 plus or minus the square root. When I typed that all into my calculator, I got the number 89, and then 2 times 2 is 4. Now the number 89, you can't break down. So again, we don't have anything to do, we don't even have a negative this time. So that means that my final answer for the quadratic formula portion is this. I can't even reduce any of the numbers on the outside because none of them, I would need all 3 of them to be able to be reduced. So this represents 2 answers because I have the plus or minus, and then remember I had 2 rational roots, so that's a total of 4, which matches my exponent if you look at the original problem. In problem number 3, we're also going to have 4 answers, and the reason I know that is because I'm looking at my highest exponent. So I know that at the end of all this I should have a total of 4, but this one, not like the one before it, does not have a greatest common factor. So I'm just going to put a check mark next to that because if I'm looking at all 5 of my terms, I don't see any of them that all have the same variable. So that step is done. Step 2 is also done for us. So this would be the process where you figure out your possible rational roots, evaluate them in your calculator, and decide whether or not you were given a 0 as your y value. So I have 2 of them, negative 5 and negative 2. So we can move on to step 3. Step 3 is going to be different than the previous 2 problems. In step 3, because I have 2 rational roots and neither of them are 0, I'm going to have to do synthetic division 2 times. It doesn't matter which one you choose to use first. I'm just going to choose to use negative 5 first because it's listed first. And remember, you do not have to switch the sign because we're given a solution, not a factor. So I put negative 5 on the outside, and then all my coefficients, 1, 7, 11, 7, and 10. So I'm going to go through this whole synthetic division process. When I get to the end of my answer, I'm going to take my new numbers that I have at the bottom to use for my second synthetic division. So if that didn't make sense, I'm actually going to do it now, so hopefully it'll make sense once you see it. So let's do synthetic division. Drop down the 1. Negative 5 times 1 is negative 5. If I add down, I get 2. Negative 5 times 2 is negative 10. If you add down, you get 1. Negative 5 times 1 is negative 5. If you add down, you get 2. And finally, negative 5 times 2 is negative 10. And so I got my 0 that I always want. And remember that 0 represents our remainder. So if I know something is a solution or a factor, I know that it's going to come out, it's going to divide out evenly. So it makes sense that I shouldn't have a remainder. All right, so for my next set of synthetic division, I'm going to use a slightly different color green. I am going to eliminate my remainder. Okay, so we're getting rid of that. And I'm doing synthetic division a second time now with my second rational root, which is negative 2. So you do synthetic division once, and then you take your answer from that first one and use it to do synthetic division a second time. So now I'm dropping down the 1. Negative 2 times 1 is negative 2. If you add down, you get 0. Negative 2 times 0 is 0. If you add down, I get 1. And negative 2 times 1 is negative 2, leaving with a remainder of 0, which again, you need to get. So it doesn't matter how many times you have to do synthetic division, you should always get 0 as your remainder. So now that I have this remainder, which I can ignore. I know that I got 0, which is important, but once you know that, we're not going to actually use it. So this is my A, B, and C. Now we can move on to step 4. So we're done with step 3. Now we have to use the quadratic formula. And I have my A, B, and C. My B value is 0. So the opposite of 0 is still 0. You can write -0. It doesn't really matter. Plus or minus the square root of 0 squared minus 4 times A times C over 2 times A. Now we have some simplifying to do. This 0 for my B value is unnecessary to write. If I could put 0 in front of anything and say 0 plus 5, it's still just 5. So the plus or minus we need, whoops, my color changed. The plus or minus is still necessary. Under the radical, if you put that into your calculator, you would get -4. And then 2 times 1 is 2. So there are two things I can, well, there's more than two things, but at this moment I see two things I can simplify. I see a negative under the radical. That's going to turn into the letter I. And I also see that I have a 4 under my radical. And I know that the square root of 4 is 2, because 4 is a perfect square. So this is going to turn into x equals plus or minus. The square root of 4 is 2. And then the negative turns into an I. Since 4 is a perfect square, my radical is gone. I'm done with it. And then it's over 2. Now the final thing I can do is I can simplify those 2's. If I divided 2 by 2, it would just give me 1. So my final answer would be plus or minus 1I, but you don't even have to write the 1. You can just say plus or minus I. So now, as I said at the very beginning, we should get 4 roots for this problem. So what I have written here in orange is 2 of those roots, and then the other 2 were given to us as our rational roots. Our last problem should have 3 roots because I can see that my highest exponent is a 3. The first step is always to look to see if you can factor out a greatest common factor. You cannot do that in this problem. I don't see any variables that could be factored out of all 4 of my terms. Step 2 is done for us. It's the rational root test. Now what I want to explain, there's an asterisk next to where it says rational roots because this is what you would see if you actually went through this whole process. So if you typed in the function, you put in all of your possible rational roots, you would see that there were 2 and only 2 rational roots that gave you 0 in your y values. But I want to go through this whole problem because it's going to show you another thing that could happen, something that's a little bit strange that would be kind of unexpected. So let's start with step 3. We're going to do our synthetic division. Just like the previous 2 problems, we're going to be doing synthetic division twice. So I'm going to take my first rational root, which is -5, and remember we do not switch the sign because we were given a solution, not a factor. And I'm going to put in all my coefficients, and we'll go through the process of doing synthetic division. So bring down the 1, -5 times 1 is -5. If you add down, you get -4. -5 times -4 is +20. If you add, you get 4. And then -5 times 4 is -20, which gives us the remainder of 0, which is what we need. That's how we know we're doing this process correctly. All right, so I've done synthetic division once. I need to do it again with my second rational root, which is 2. And please remember that we're not using that 0. Once we get that 0 to tell us we did it right, now we can drop it. We don't need it anymore. So I'm going to drop down my 1. 2 times 1 is 2. Add down and you get -2. 2 times -2 is -4. And if we add down, there's my other 0. So we're done with step 3. But here's the catch, and this is actually easier, even though it looks different. So the past 2 problems when we did synthetic division, actually the past 3 problems, we were left with 3 numbers and then a remainder of 0. This time we only have 2 numbers and a remainder of 0. So I want to explain something. We started with x cubed as our highest exponent. Every time you do synthetic division, your degrees drop by 1. So I started with x cubed, and then this was x squared, x to the first, constant. When I go down to my next level, now I have x squared, x to the first, constant. Then I go down another level and I drop down to just x and constant. And these last numbers here, like this was my remainder, that's my remainder. So I don't need to worry about those. So what this is saying, I'm going to actually write this out as a polynomial, is that I have 1x minus 2. So that's what I have left. Now, normally we have something that we use the quadratic formula on. And essentially what we're doing is we're setting it equal to 0 and seeing which x values would give us 0. So if I take this and I set it equal to 0, all of a sudden that becomes pretty easy to solve. So step 4, we're not even going to have to use quadratic formula this time. We're just going to have to solve. So step 4, I'm just going to write, we're going to solve x minus 2 equals 0. This one is a one-step equation, add 2 to both sides, and I get x equals 2. So there's my third solution. So I had 2 solutions here. This is my third solution that we just figured out for a total of 3 solutions. Now the thing that I want to make sure I make really clear, in the previous lesson I talked about how I have 3 total roots for this problem. 2 of them were rational. If I was to do the quadratic formula, that always gives me 2 solutions. And so I want to make sure that it's clear that I can't get 2 solutions, because if I got 2 more solutions, if I used quadratic formula and I got 2 solutions, that would actually give me 4 answers, and I know I can only have 3. So that's how you know that you have a double root. And if you notice, I'm going to highlight here, I have a 2 here and a 2 here. So I actually have a double root. So that's what's going on here. I have a rational root that only shows up once when you look at your table, but when you actually work through the whole process, you can see that it actually happens twice. And that's when those weird things happen, like you have 2 answers, but you know you have a third one, but it can't be something that has a square root, like a plus or minus in it. So it has to be that one of your rational roots was a double.